All right, today we are pulling back the curtain on one of the first real superpowers you get in programming, the while loop. Seriously, if you've ever wondered how a program can just keep doing something, or how it seems to wait for you, this is the secret sauce. So let's dive in.
Think about it for a second. How do you tell a machine that can perform millions, even billions of operations a second to just hold on? How do you make it repeat something over and over again until just the right moment?
The perfect example is the title screen of pretty much any video game. It doesn't just play its little intro animation once and then shut down, right? No, it's in a loop. It's constantly playing the music, showing off the cool graphics, and behind the scenes, it's asking one simple question, again and again and again. Has the player pressed start yet? Nope. Okay, do it again. That simple idea, that constant waiting and checking, that's exactly what we're talking about today.
And that elegant tool that makes all that constant checking possible? Well, that brings us right to our star of the show, the while loop.
So what is it really? Simply put, a while loop tells a computer to do a chunk of work as long as a certain condition is true. Here's an analogy I love. Think of a bouncer at a club. Their rule is simple. While the club is not full, keep letting people in. The bouncer's whole job is to constantly check that condition. Is the club not full? And if the answer is yes, they perform the action, let someone in. Then what do? They check again. That's a while loop in the real world.
What's so powerful is that every single while loop, no matter how complicated it looks, boils down to these three simple steps you see here. Step 1, you check a condition. Is the game still running? Step 2, if that's true, you execute the code inside the loop. And step 3, you repeat. You go right back to the top and check all over again. It's this simple, powerful rhythm. Check, act, repeat.
Okay, but what if you don't want the loop to just run its course every single time? What if you need to jump out early, or maybe just skip a single part of it? Well, that's where you need to take charge of the flow.
Yeah, because once you're running inside that loop, things can happen, right? What if something unexpected occurs? What if the user hits the escape key? You need a way to change the plan on the fly, right in the middle of a repetition.
And lucky for us, we have two main tools for that: break and continue. Think of break as the big red emergency escape hatch. You hit it and you are immediately out of the loop. Done. The repetition is over. Continue, on the other hand, is totally different. It's like the skip track button on your music app. It doesn't stop the whole playlist, right? It just skips the rest of the current song and jumps to the next one. In a loop, continue skips the rest of the code in the current cycle and goes straight back to the top to check the condition again.
Now, this amazing power to create loops, well, it comes with a great responsibility. And that leads us to a classic trap that every single programmer falls into at least once: the never-ending loop.
Yes, the infinite loop. This is the one you really have to watch out for. It's basically a piece of code that gets stuck repeating forever, and it'll usually cause your program to freeze up or totally crash. It's the digital version of running on a hamster wheel with absolutely no way to get off.
And what causes it is simple. It's a loop where the condition you're checking never ever becomes false. Remember our bouncer? What if his rule was while 1 equals 1, let people in? Well, 1 is always going to equal 1. He'd never stop letting people in, and the program would just run forever. That's the danger right there.
So how do we dodge this bullet? It all comes down to making sure your loop has an exit strategy. First, and most importantly, whatever condition you're checking must have a way to eventually become false. Which leads to the second point: the thing you're checking, that variable, it has to actually change somewhere inside the loop. Before you run your code, always ask yourself this one question: how does this loop end? If you don't have a clear answer, you might have a problem.
Okay, so we know what a while loop is, how to control it, and we know the big pitfall to avoid. The final piece of the puzzle is mastering the strategy, knowing exactly when to use one.
This is the classic question, because in your programming toolbox, you have another popular tool for repetition: the for loop. So when you're staring at a problem, how do you know which one is the right tool for the job?
This table breaks it down beautifully. A for loop is your best friend when you know the exact number of times you need to repeat something right from the start. Think, I need to count from 1 to 10. A while loop, however, is the star when the number of repetitions is unknown. It's perfect for situations like waiting for a user to type quit. You have no idea if they'll do it on the first try or the 50th. So for for loops, it's all about the count. For while loops, it's all about the condition.
And that's really the heart of it right there.
This is the key takeaway. If your finish line is a set number, like running 5 laps around a track, you probably want a for loop. But if your finish line is a condition, like keep running until the sun sets, well, that is a perfect job for a while loop.
So now that you get this fundamental logic, how to teach a computer to wait and repeat, it really makes you think, doesn't it? If you look at all the repetitive, tedious things you do every single day, what's the first thing you'd want to automate? It's a fun question to ponder. Thanks for tuning in.